What's the number one problem with all DIY dust collection systems? Well, to be honest, I have no idea what the number one problem is, but today I'm going to pretend like I know the answer and say it's remembering to turn it on when you're using a power tool. And how do you do that when it's way up here? I guess I could get a long stick and reach from the ground and flip the switch every time I turn the table saw on, but I got a much better idea. I'm going to show you how I did it and automate this entire system. Stick around. So what am I talking about here? Well, that's a good question. To answer that, we'll have to travel back in time a few years when I made a video about this product right here, the iSocket Auto Switch. Come with me. This is an excellent product. As I mentioned, I made a video a few years back. I'll link it up on the screen somewhere if you want to check it out and learn more about it. But after years of use, I've discovered one fatal flaw with it. It is simple to use. Just plug the switch into any standard outlet in your shop. Take your dust collector, which for the example of this video, I'm just using a shop vac here. Plug it into the port marked vac. Take whatever tool you're working with. We'll use the table saw today. Plug it into the port marked tool. Turn the switch on the shop vac or your dust collector to the on position. And then as soon as you flip the power on whatever tool you're working with, it will send power to the dust collector at the same time. And then as soon as you turn it off, it will let the dust collector run for about 5 or 6 seconds, I think, to clear out the hoses for you. I'll demonstrate. Dust collector going. Tool off. Dust collector still running. It's a great product. So you may be asking yourself, what's the fatal flaw with this setup? Seems to work perfectly, right? The answer is amperage. The problem with this design is you have a single switch here connected to a single outlet on a single circuit. Now in a garage or a shop, usually those are 20 amp circuits, but you have 2 power tools plugged into that same circuit drawing power at the same time. Now you can get away with that with a smaller power tool, say a sander, smaller dust collection system like this shop vac here. But when you start running bigger tools like a table saw, a planer, a joint, or something like that that has a high amperage draw, and try to run a large dust collector off at the same time, you're going to have problems. That circuit's going to be popping like that almost every time. And that's exactly what I found with this setup. Okay, so how do we solve the problem of overloading the circuit by having both the tool and the dust collector powered to the same circuit through a device like this? Well, we got to go old school. And I mean that literally. This is the old school auto switch. It performs the same basic function as this, but instead of doing it internally, detecting the current flowing from the tool, sending current to the shop vac or the dust collector, it detects current being drawn from the tool and wirelessly sends a signal to a receiver module just like this, which is then plugged into your dust collector. Now you can separate the tool and the dust collector on 2 different circuits. I have mine right now temporarily mounted to this piece of wood with a couple magnets on it, so I can set them at my outlets like this and then move it from tool to tool as I'm using it. But in this video, we are going to solve this problem too, and that's really what this video is actually about. So how do you automate the entire system for all of your tools? Well, there's a couple ways to go about that. So the easiest way to automate your entire dust collection system for every one of your tools using this auto switch from O School would be to just buy a transmitter for every one of your tools. But at around $65 each for these transmitters, that could get really expensive really quick. But I have a much simpler and much less expensive solution that will accomplish the same thing using just one of these transmitters. So essentially what we're going to do is build a giant one of these and have it permanently hardwired in. This is a power strip, because at the end of the day, this switch here doesn't really care how the tools are connected to it, regardless if the tool is plugged directly into it or plugged into it through something like this, where you have multiple tools plugged into it at the same time. It's just looking for that current to flow so it knows to send a signal up to the receiver to turn the dust collector on. but we're going to build it ourselves. We're going to use this. This is electrical conduit. And the great thing about that is it's going to be permanently hardwired in, and it'll always be ready to go. So I'm going to go ahead and get started. I'm going to show you how we're going to do all this. I'll put links in the description to everything you'll need to accomplish this project. And let's just get started. So I just want to say one of the great things about building a power strip like this yourself for a dust collection system is you can design it however you need it to be. I can have these boxes at whatever location I want. I can change it as my needs grow. So it's a very modular and a very customizable system. So one of the first things we need to do here is get our 4-square box prepared. And they have these little knockouts that you can pop out, and they pop out these little about quarter-sized pieces of metal. And then you take one of these EMT set screw connectors, undo the large nut on it, undo the nut, pop the connector in there, and just spin that on there. And the way I like to do these is I run the nut all the way down, and I have the set screw approximately about the 90-degree mark. And just take a pair of channel locks and grab the head of the connector and spin it to where the set screw is pointing forward towards the open side of the box, and that will usually tighten that down and then give you access to the set screw for attaching the conduit later. And then what I'll do is I'll mount this box here right below this one, and then I'll start making my boxes and bending my conduit on down the line, and I'll show you how that works. So what I want to do is start mounting our box here. I've already decided that I want it just slightly below the level of the existing outlets. I'm going to take a magnetic level here so I can get the edges lined up, and that will hold it in place for me. Take my tape measure and actually choose a height, specific height. And I'm going to have it set, the bottom of the box is at 39 inches. And then I will just drive in a couple screws here. And make sure the box itself is level too. First one's done. So some of the electrical connection details I'm going to just gloss over. I've already covered those in videos before. I'll put links for you up on the screen, maybe down in the description if you want to learn more about how to actually wire some of this stuff up. I'm just concentrating more in this video on building this power strip for you, showing you how you can do that. So I've decided to put this next one down the line directly below this outlet as well. So it'll be the same process as before, just mount the box. But the way I do these when I'm adding conduit to it is I will mount the box with just one screw temporarily first. Same way I did it the first time. I use the level to hold it in place. My height. Attach one screw temporarily, like so. And then what I want to do is take my box-to-box measurement so I know how long to cut the conduit. What I'm going to do here is measure the exact distance. I'll lose a little tiny bit of distance making the bends. You'll see that. Alright, so what I'm going to do is measure and mark the conduit. And if you don't have a porta-band saw like this, you can just use a hacksaw to cut the conduit. And after you cut it, you want to take one of these conduit reamers and deburr the end so you don't have any metal burrs that'll poke into the wire, cause a short. Puts a nice little chamfer on the end of it too, so it'll slide into the connectors easier. Alright, so the next thing I'm going to do is bend what's called a box offset on the end of it, which just puts a little kind of an S shape sort of at the end of it, because these connectors aren't flush with the back of the box. They're actually out a little bit, so you need to bring that end of the conduit out away from the wall just a little bit. Now, if you don't want to learn how to do this, or don't want to have to buy a conduit bender, there are pre-bent connections you can just add on to straight pipe. I don't know how much they are, but I'll try to find them and put a link in the description. But basically, got to the point where I just do this by feel now. Usually bend a 10-degree bend in the conduit. One that way. Sight down it so you are making your bend straight. So when you bend the box offset on the conduit, it creates this little kind of S curve at the end that kicks the conduit out away from the wall just a little bit so that it can slide right into these connectors here. I'll show you what I mean. So the conduit would sit flush on the wall like this. Kicked out away from the wall, and then the box will just slide right onto the conduit just like that. So we'll get this mounted. I'm going to start with the box at the end that's permanently mounted with the 2 screws. Conduits would just essentially slide right into that connector here. And then take a screwdriver. What I like to do is just lightly cinch down that set screw just to hold it in place. You take your finger and slide it in there and make sure that the conduit's fully seated into the connector. And then we'll take the next box in the row, slide it on, grab your level, throw it on the conduit so that you can get the conduit level as well. Nut conduit should be fully seated on this side as well. And I can go ahead and snug this one down. I'll grab my level again. Make sure I've got this box level now. Here we go. Box number 2 is installed. You'll want to grab some of these 1-hole straps, or if you prefer the 2-hole strap, to support the conduit. One each of these 1-hole straps. And towards the end here, you probably won't be able to see this one because the hose is in the way, but just like that. And finally take your screwdriver and tighten down the set screws fully. There we go. And then all I gotta do is continue on down the line, setting these boxes where I want them. Pretty simple doing this run here. When I get to some of the aerial drops, there'll be a little bit more fancy bending to do, but the rest of this is pretty simple. Show you a little trick here to conserve material. I have this shorter piece here and another shorter piece here, so I don't need to cut or use one of the full 10-foot pieces. They have connectors you can buy that look like this, that you can essentially splice 2 pieces of conduit together, either conserve material or if you have a really long run, or in the event that you have to do 2 bends in a single piece of conduit and you get them kind of out of alignment, don't worry about it. Just cut it in the middle, throw one of these guys on there, and you can rotate that whatever way you need to. So here's a good example right here. I overbent that one a little bit. And if you do that, you can go back and fine-tune these bends a little bit. Basically, if you overbent it a little bit, you just put it in the opposite way and bend it back more straight, depending on what part is off. But I'm kind of glad I did that so I can show you if you don't get it perfect. Doesn't matter, you can make a little adjustments as you need to. That side's in there pretty much perfect. I'm going to throw my level on this section right here. And whenever you have any kind of a connection, like this coupling right here, you want to support it with a strap. So I'm going to throw another 1-hole strap, make sure this is level. Okay, so the final box on this row here is going to mount right about here. And the way I'm going to power this up is I'm going to add what's called a strain relief to one of these knockouts. And then I'm going to have a section of extension cord come out through that strain relief. The strain relief provides support for that extension cord so it doesn't get bent and broke too many times. And then that is what we'll plug into essentially power, but it'll be powered through that transmitter, of course. And I'm going to put one more connector here on this side. I'm going to have to run some conduit down the wall and then up and follow this PVC conduit here on the dust collector, for there's two tools right over here you can't see right now. I've got a drum sander and my drill press. Those bends will be a little bit more complicated than what we've got going on here, but really not that much worse. You want to make sure you do a pretty good job reaming these two. As you take a quick look at them, and also rub my finger along it just to make sure there's no burrs sticking up still. No bill burrs sticking up on it. You don't want any bill burrs on your conduit. I like Bill Burr. Fantastic. Been a huge fan of his for years, but you know, I really don't want him on my conduit, to be honest with you. So alrighty, let's take a look at this piece of conduit I just bent. It's a little complicated. It has 3 bends in it. I want to show you how they all work together. So we've got the 90-degree bend here, which is going to take it up and over and shoot the conduit that way so I can attach it to the tools that are behind me. I've got the kick right here that's going to bring it away from the wall. And of course, I've got the box offset at the bottom there. I'm going to drop it into the box just like that. And now you can see how all 3 of these bends work together. The conduit's flat up against the wall, so I can attach it with the straps. The box offset down here, so I can drop it into the box. This kick right here brings it away from the wall just a little bit to clear those obstacles there. The other conduit right there. And it also brings it far enough away from the wall so I can run it along the face of the 4-inch PVC pipe up above and shoot it on down that way. Now I realize that I am glossing over a lot of the conduit bending portion of this project, but that's because that's not what this video is about. This video is more about building the system and showing you how you can use something like this to automate your dust collection. If I do get enough questions and comments about the conduit bending, maybe I'll make a separate video, show how to do a few of these bends in a little more detail. Well, if you were annoyed before when I glossed over the conduit bending portion of this, prepare to be annoyed again. I'm really going to gloss over the electrical portion of this, the actual wiring. Mainly because I've made several videos already explaining how to do wiring like this. I'll put links on the screen and in the description if you want to check those out. But for now, I'm just pretty much going to get this done. I will tell you one thing about it though. I am going to wire this in parallel to avoid the voltage drops of wiring it in series. And again, the videos I have explain the difference there. That's pretty much it for pulling the wire in. All I have left is to make all the electrical connections, set the outlets, put the cover plates on, and we are basically done with this project. If you've made it this far in the video, thanks for sticking around. I'll have a special bonus for you at the very end. I think you'll like it. Wait. I changed my mind. I take it back. I am going to give you one tip on the electrical wiring portion, since we are using metal conduit here, is you need to ground your system. You do that through, you can get these little ground wire pigtails with a ground screw on it already, and there is a spot in the back of the boxes here. It's a threaded hole that these fit right into, and you just add this into your connections. And you want to do this at every box. All right, well, that's it. We're all done. Everything's wired up. We're ready to test it out. But first, I want to talk about this. If you're going to do some electrical wiring, you should probably pick up one of these. It's an outlet tester. This will allow you to plug this into an outlet, and it will tell you if it's wired correctly. This one is really nice because it has this added feature of a display here. It gives you the voltage and some additional information. So to test this out, what I'm going to do is take my lead here, which is the end of an extension cord that I wired into the entire dust collection system power strip here, and just plug it directly into a hot outlet right here. I'm not going to plug it into the auto switch just yet because we want to test to make sure we're all wired up correctly. So now if I take this and plug this in, to this outlet here because everything is wired in together and I'm plugged into power here, you'll see that the green light will come on indicating that it's wired correctly. And I'm also getting a voltage reading of 123 volts. So that tells me we're wired correctly and we have good voltage here. And now for the moment of truth. Basically how this is going to work now, I'm going to plug this into the auto switch, which is a transmitter. Plug my transmitter into power. Now all my tools are connected to this auto switch through this one connection here. So any one of these tools that I turn on now will automatically kick on the dust collector. Let's give it a shot. Well, okay, might as well go to the end of the line here so we can test it out. Let's open up the blast gate. And then as soon as I flip the saw on, because everything's connected, should kick the dust collector on too. Shut the saw off, the dust collector will run for a few seconds to clear the lines, and we're in business. Dust collector still running. Looks like it works great to me. All right, so for those of you that stuck around to the end, I did promise one extra bonus tip, and this tip is going to help get the most use out of a system like this. So obviously this is designed to kick the dust collector on as soon as you turn the power tool on, but what happens if you've got something like this in your shop? Just a standalone dust port that you could use to clean up. How do you get the dust collector to come on now when you've got something like this? Well, obviously one way you could do it, and don't recommend it, would be to just flip one of the power tools on and then use your dust hose and start cleaning up. But the problem there is that's a little dangerous because you have a power tool running and you're not paying any attention to it. You're off doing something else cleaning up. So what can you do? Well, there's an easy solution. Remember earlier I told you that the whole basis behind this idea is that transmitter doesn't really care what tool is hooked up to it or how they're hooked up. It's just looking for amperage. And it's not looking for much, less than half an amp. So all you really need is a device that can draw just a little under half an amp and the dust collector should come on. So just grab something like this, an ordinary drop light. Plug it in to where one of your tools are plugged in and turn it on. The dust collector will come on. Now we can clean up. It's just that easy.